All right, looks like we're live. Going to talk about testing today. So I'm waiting until that happens. You'll have the pleasure of watching me stare at the screen. So what we're going to do for Q&A, because live Hangouts are a little different, you can just add questions into the group chat, and I'll be watching that, and as they come in, I'll be happy to answer them. So it looks like we've got a couple of viewers who are on. I expect more to take a look at this. To trickle on in. So we'll give people about another minute, and then I'll just dive right into the talk. There are a lot of things that I want to cover. Testing is something that is very important, so I'm really excited about having this talk. This is definitely something that we want to have more regularly, having more technical talks, not only for me, but other people from the team about, certainly things that we're doing in Concourse, but things that are also just good engineering practices in general. So I'm just going to go ahead and dive in. People that are watching, thanks for tuning in. And those who aren't or could not make it or will be late, they'll certainly be able to catch the recorded version of this. So I'll just go ahead and start. If you don't know who I am, my name is Jeff Nelson, and I am the founder and CEO of a company called Centropy. And Centropy is the sort of leads development for Concourse. Concourse is an open source database project that's been going on for quite some time. We've got a great community of people, people of varying skill levels, some people who are very skilled at coding and some people who are just now starting out, which I think is great because we really, really like to mentor people and we really like to give them an opportunity to contribute to a very big project and learn some stuff. So that's enough about introductions. I'm just going to dive into the topic. And again, for anyone that just joined, if you've got questions, go ahead and type them into the group chat and I'll answer them that way. This talk is about testing. So, test all the things. And what I'm going to focus on, I'm going to focus at least the structured part of the talk, and my slides are going to be focused on how we do testing in Concourse and some of the philosophies behind it. But really what I want people to take away from this is how can they write tests for Concourse, within Concourse, contributing to this project. How can they write tests? Because testing is very important to what we do. I know some people had questions just about testing philosophy and some of the logistics of testing. I'll try to touch on that in crosstalk or at least as answers to questions. But really what I want people to take away from this is, okay, how can I actually go and write some tests the correct way? And what are the tools that I can use and how can I leverage some of the stuff that already exists? So I'm going to go ahead and share my screen so people can see my slides. So hopefully people are seeing a presentation. And I'll periodically break out of this just to see if there are questions about anything. So, you'll see me occasionally switch back to see if there are questions. So test all the things. The first thing that I want to mention is that testing is non-negotiable. That's one of the things when I do code reviews, there are a lot of things that I am a stickler for. I'm a stickler for documentation, formatting of code, how it's structured, things that may seem very nitpicky. I'm very much so a stickler for those things because I think code in and of itself is a product, right? Especially in an open source environment. Your source code is a product, and so you've got to treat it with the same care that you would a user interface or anything that a user would typically see and interact with. And testing is one of those things. It is non-negotiable. I won't merge code into any of our repositories or any of our projects if it is not tested. And one of the questions that one of our engineers asked beforehand, should we enforce test-driven development for our open source community? And my philosophy on TDD is, in general, I'm not a zealot about most things when it comes to software. I'm not agile or die or test-driven development or die. I think there are lots of tools and frameworks out there that all have a place. My philosophy on TDD is that there are certainly good practices that it helps to hone, but one of the things that I think TDD does is it creates this perception that the purpose of testing is to know that something works, right? So you write a test and it fails, and then you write the code to make the test pass. And so developers have this perception that the purpose of testing is to know that something works, but that's not true. That is not true at all. We don't write tests to know that something works. We write tests to know that something is broken. And let me clarify that. The purpose of writing tests, right? The purpose of writing unit tests, automated tests, integration tests, is so that we know when something breaks. When you're dealing with a large code base, you're dealing with multiple committers, multiple contributors over a long span of time. It's very, very hard to keep. Testing is the only way you know systematically if something breaks, right? I can't tell you how many times, I've been working on Concourse for I guess about three and a half years now, and I can't tell you how often I'll go back into the code base to try to figure out how these pieces fit together or why something happened. And even as the original author of this software, it can be quite daunting, and it takes me a while to really get into the groove of things. So if things were randomly breaking and I had to go in and debug something and figure out what happened, if we didn't have tests, so many tests in this project, it never worked. This thing would never work, and we'd never be able to ship or release anything. So the purpose of testing is to know that something is broken. That's the purpose of testing. And I'm gonna pause really quick. See, there are no questions, so I'm just gonna continue going, right? So that's my philosophy about testing. It's non-negotiable because it's the only way you know systematically that things work. When you write a test, you're essentially saying, this is a contract, and I'm testing that given these inputs into this function or this whatever software, whatever it is, I'm going to get these outputs, and that's the contract. And my enforcement mechanism is this test, which I can have repeatedly run every time code is changed. So as soon as there's a commit, I know about that. I know what test broke, so I know where to look, and I have a mechanism via which I can debug what broke. And so let's start with unit testing, because there are lots of different kinds of tests. There's unit testing, there's integration testing, end-to-end testing, automated testing, manual testing, black box testing, white box testing, and I'll touch on some of those. But a unit test, it is the most basic level of testing that you can have, right? It should cover the smallest use case possible, and it should have minimal, ideally no dependencies. So when we talk about unit testing, we're actually talking about just a unit of code. For some reason, it's really hard for developers, at least initially, to wrap their heads around a unit test, because when we think about software, we think about building systems that have multiple components, and immediately people think that they should test those components interacting with each other, and that's wrong. What you should do initially is test those individual units in isolation, because if you just build something and then you try to use it and it breaks, you don't know whether it's one of the components that broke, and if so, which one, or you don't know whether it's the glue among the components that broke, and if so, well, which part of the glue? So what you want to do is you want to start by having unit tests that test individual components, and or no dependencies. You want to use mocks for any of your dependencies. There's a great library in Java, and they're in other languages. They're similar libraries. It's called MyCourse, and it's a great library, and we use it within Concourse to create mocks within a unit test. So you'll see this code snippet here. There are some comments with little context, but this is taken from a snippet in the buffer test class. And as some of you may know, in Concourse, right, the buffer is where data is initially written before it's transported to some permanent destination, right? The buffer is a memory map data store. It's stored on disk for durability, but all the reads happen from memory. The buffer store, what we want to test is simply that, hey, I can write some stuff, but I can also transport some stuff, but I don't actually want to test transport it into any particular store. I just want to transport whether my buffer class can do its part. Because remember, in a contract in software, there are two components, right? There's someone that's giving input, there's some function or some method or some unit, right, that's performing some logic, and then there's the output. So in a unit test, what you want to do is you want to test whether your unit, given some input, is delivering the correct output for that input. But if in order to perform that logic, your unit has to interact with other things, right, then you want to mock away those things. So this mock here is literally saying that, hey, for the permanent store interface, right, I don't care what it is, just create some mock of that, and don't do anything when this method is called, right? This accept method in the permanent store class, don't do anything, because I don't actually care what the permanent store does in that accept method. I don't care, right? I simply just want to mock the existence of that store because I need it, right? I need that thing, it's a dependency, but I don't actually care about the logic it's performing because that's outside the scope of this unit. The next thing is we want to use randomized data for inputs. And I apologize here. I think I have the wrong picture there. So what I'm going to do is I'm actually going to go into the source code and we're going to do it live. So you actually want to use randomized data for inputs. And so I'm going to show an example of this and I'm going to talk about it, because if you look through Concourse code, you'll find it everywhere, right? You'll see that a lot of times, not a lot of times, but all the time, when we're doing stuff, we'll sort of use this test data class and we'll get a simple string, or test data, you can get a bunch of stuff, right? You can get objects of different types, you can get booleans, integers, longs, whatever the case may be. And the reason we do this is, and I'm gonna go back to my presentation now, I'll just delete that because it's useless. The reason we do this is because we want randomized data for inputs. Now, this is something that's greatly debated. I've had conversations with a lot of smart people about that. And the pushback is that, well, when you use randomized data, you have to create two implementations. You have to essentially create another implementation within your unit test for the random input, right? So let's say if you're building a calculator and you want to test that your calculator is correct, and you've got some implementation of that. Well, if you use random data for that calculator, within your test, you're going to have to re-implement the logic for calculating in order to know what to expect based on that random data. So I do concede, but we use it in Concourse specifically because, one, we're building a database. So we want to be able to test as many possible permutations of input without explicitly writing all those test cases. And so you'll notice if you look through the code in Concourse, and I'm going to go back again and just briefly check, no questions, cool. If you actually look within the code, right, we're getting random input, but we know the types of input, right? So we know we're getting a string. So we at least know the kind of data we want. But what that string actually is, we don't care, right? So for this method here, where I'm trying to test something, right? So essentially I'm adding a key as some value into some record. That's what I'm doing. And so normally you say, well, add foo as bar in record 1. Like you just have that static, those sort of static values. But by using these randomized data points, these randomized values that we know are certain types, right? So we know we're getting a long, we know we're getting a string, right? We know that we're getting a T object, which is what the value that we need to add. So we know the kind of data we're getting, but we don't know exactly what that data is. That's actually saved us in so many cases because it uncovers edge cases that we didn't think about, right? Especially with strings. So if you're getting strings and you get certain characters in the string, or you get certain spaces, or all these different things, you get this variety of data that really helps to uncover edge cases when randomly a test will fail because of a certain type of input. And then we can go in and say, okay, well, this is an edge case we missed. We actually got to cover this in the code. So using randomized data for inputs has been really helpful. And so there is a Concourse unit test core project. And this is sort of the basic building block for any of the unit tests that we do. And one of the things that I want to be clear about with Concourse is that we've done a lot over the last 3.5 years in building a very innovative database that does a lot of cool things technically with Java and systems, distributed systems, and all kinds of about all those things. I mean, we could do tech talks on so many different components of it. But one of the things of which I'm most proud is what we've done with testing. We've built so much infrastructure and so many frameworks around testing because it's so important. And this is what this talk is going to outline. We've done so much of that. And the first is the Concourse unit test core, that project. It provides so much scaffolding that's important. And an example of some of the things is that you can do common setup before tests. And so in JUnit does provide some things. You can have test watchers and things that allow you to do some of these things. But we've really taken that and built on make it more obvious for developers, right? So if you're writing a unit test and before every single test you want to run some action, then we've got hooks in the framework that allow you to do that. The same thing if you need to tear down some stuff, if you need to clean up after every unit test, right? Instead of copying that code in different places, right? We've got hooks that allow you to go in and do stuff beforehand and also do tear down afterwards, right? And I think that our API for doing this is much more apparent than JUnit's API because, again, you're just writing another function, right? For developers, I find that it's very easy for us to do repetitive things, right? So if we're writing test functions, then if we want logic, we just want to write another function and have some magic just go in and take care of that for us, right? Another thing that I think is really cool is variable tracking for debugging purposes. And so when you're dealing with random input, one of the things I mentioned is that having randomized input has saved us so many times with respect to finding edge cases that we didn't think of or we didn't uncover before because of special permutations of the input. And the reason we were able to say, okay, well, this test failed, how do we know what the inputs were since they're random, is because we can track it, right? So the Concourse unit test core framework provides this variables construct that allows you to register, give you a way to inspect the stack after a method executes, or even while it's executing. It doesn't really give hooks to do that. So for developers, we provided this construct where you can literally register any variables you want, right? And you give it a name and the values are there. And even if those values change, it's tracked. And then what happens, if you've got a test failure, then all of that stuff is logged for you. So for our continuous integration system, when these tests are running and they're running with randomized inputs and something fails, we actually get reports of this, and we know exactly what the registered variables were, any exceptions that were thrown, so we can actually then go in and recreate that exact, creating a randomized test. I'm going to create a repro test. And a repro test is going to tell, I'm going to be able to specify exactly what values I want, like a regular unit test, but I have that output from the report to know exactly, well, what should I do, create here in order to create that exact same state, and then I can go in and do some debugging. So that's sort of the idea about unit testing. Any questions about that before I go on and continue with the presentation? If anyone that's watching and is on the Hangout, if you've got questions, go ahead and type them in, or you can also shoot me an email. I've got my phone right here. So if you've got questions that you want me to answer, just go ahead and shoot me an email, and I'll. If there are no other questions, then well, okay, we've got a question here, so let me go ahead and answer that. So the question is, so Concourse is distributed. Concourse server is running in one machine, and does that mean that Concourse runs in a cluster of machines? So that's a great question. And the distributed protocol is something that we are going to be unveiling in the coming weeks, hopefully. Hopefully it's on the order of weeks instead of months. I would estimate by the end of the summer into the early fall. But to answer that question, so, you know, you can have multiple instances of Concourse server running on one machine. But for the purposes of the distributed protocol, you can have multiple Concourse servers that communicate with one another, and they replicate data among each other, but they also partition it. So if you've got a ring of data, then you can say, well, I want these instances of Concourse to handle this part. I want this subset of data, and another group of nodes to handle another set. And so you can partition it, but also you can also replicate it. And we're actually doing some very interesting things with the distributed protocol. So I'm a big, really interesting things to offer highly available distributed asset transactions at scale. And we'll be talking about that more in detail, perhaps maybe in another Tech Talk format, hopefully by the end of the summer, when the alpha of that rolls out, and we can really get some feedback from people. But yeah, if there are more questions, can continue to email me or post them on various forums where I can see them. I'm going to jump back into the presentation now and go on to the next topic. So we talked about the variable tracking, right? And so those are unit tests. Integration tests are a step up from a unit test. So these really cover workflows. And for an example of that is in Concourse, communicating from client to server, because Concourse server is a server, as the name suggests, and then there are clients that interact with it, right? And so you really want to be able to test how the communication from client to server happens. So the point of the unit test, you know, we write unit tests on the server side, and we also write unit tests on the driver side, right? So we want to test that the driver in isolation is doing what it's supposed to do. It's keeping up its end of the bargain, creating the right inputs, and we also want to test that the server is keeping up its end of the bargain and creating the right outputs given some input. But then the integration test tests whether the client one another, so that the input that the server thinks it's supposed to get is the same thing that the input that the server gets is the same output that the server is passing over the wire. And so you can kind of visualize the integration testing framework like this. We have the test runner, right? And what it does, it actually embeds an instance of Concourse server for every test. So every single test method, what automatically happens is an embedded instance of Concourse server is start up, It runs on port 1718, that's hard-coded. And then there's a client specifically for that instance that's running. This is all managed by, is that you can write unit tests that have this instance of a client that interacts with some server that you don't have to manually start. And for integration testing, right, we're at the point where we can't mock away the server, right? We can't mock away Concourse server because what we're testing is the communication from the actual client to the actual server. But we don't want people to have to manually, you know, if people have ever used the database before, they want to test their code works with a particular database, then it can be frustrating because you've got to manually have that database just running, right? You've got to have it up and running all the time, and maybe you've got to write scripts to clean out data and stuff. That's ridiculous, right? For our integration code, and then the framework's going to actually take care to start up an instance of Concourse server. It's going to be embedded in the same process, and it's going to give you a client that interacts with it, right? And so you get this real nice ability where, hey, this is a test method. And all I've got to do, right, I get this client variable that I can interact with. It's actually an instance of the Java client. So this is Java code. I'm actually using the Java client that I'd actually use in a real project. I'm actually using that same thing, and it's automatically interacting with the server. I don't have to know anything about that server. I don't have to know where it lives, where it's storing data, because the integration testing framework automatically manages that for me. It'll automatically start this, automatically clean up the data from disk so it doesn't hang around, and it does this before and after every single test. Before every test, I get a new Concourse server, a new client connection, and I know it has no data, right? So it's in a known state. And then after that test method, that server is stopped, the data is deleted, the client connection is closed, and then it moves on to the next test. And so that's the sort of beauty of the integration testing framework. Now I want to spend a little bit of time talking about this notion that sometimes you'll seemingly write you'll write both a unit test and an integration test for something that seems like the same use case, right? And if people have questions, feel free to type them now or email me those. But you'll write, you may be doing a bug repro, or you may be doing sort of a test for a feature, and you're writing both a unit test and an integration test, and people will say, well, isn't that repetitive? And the answer is no, right? It's not repetitive because, again, remember, for a unit test, if you're working on a feature, or a lot of times when you're working on a bug repro, you're usually dealing with multiple components. And so what you've got to do is you've got to test those individual components, right? So if you're doing a bug repro and one of those components is broken, you've got to write a unit test that, one, tracks to verify will be there so that we know that it doesn't break again. But you've also got to write that integration test to ensure that the communication from the client to the server actually goes through in the way that it's designed to happen. You've got to be able to do that. And so, yes, sometimes it may seem like if you look through our testing, you may be tempted to say, well, these are repetitive tests. I see you're testing atomic operations as a unit test, but then there's also some stuff about atomic operations in the integration test. And the answer is, we're not being repetitive. We're doing our correct diligence. We're testing the individual components, but we're also testing those things integrated and communicating with each other. So now I'm going to continue on with my slides. And now I'm going to talk about E2E tests, end-to-end testing. A lot of people don't understand the difference between end-to-end testing and integration testing. End-to-end testing is bringing third-party components into it, right? So in Concourse, we've got a lot of components internally, and our integration tests will test how those components interact with each other. But we've built this E2E test core framework that allows third-party developers to write realistic test cases for their code. So if you're building some web app and you're using Concourse, do what I just said is annoying, manually start up the database and have to manage that separately. We've got an end-to-end test framework that will allow you to do that in the same way that we do that in our integration test. So everything that I talked about, variable tracking, automatic resource management, all those different things, that automatically happens in this E2E test core framework. But there's a little wrinkle on it. So if I go back a couple of slides, right, this is how our integration testing framework looks. The Concourse server is embedded and the client interacts with it, they're both embedded. In the end-to-end testing framework, it is actually not embedded. And notice I'm highlighting the word realistic here, and that's intentional. When you're developing a third-party application that uses Concourse, right? So you're building some web application, or you're building whatever the case may be, you're storing data in it. Your database isn't embedded. Your database probably runs on a different system. Your database is not embedded in the same process as your application. It doesn't. That's not how we develop software in the real world. So E2E test framework, we wanted to make sure that we could have realistic scenarios where if we're testing how data goes from your client, your application to Concourse, that it actually has to go through a socket layer, that it actually has to do what it would do in production. Really cool, because since it runs in a separate JVM, that separate JVM is completely managed by the test JVM. So yes, it's in a separate JVM, but you, the developer, or you, the test runner, don't have to manage it yourself. The test runner actually still manages that separate JVM, right? There's separate processes, but the test runner can still manage it. And the test runner embeds the client in itself, right? Because again, it's your client, your code is going to be in a separate process from Concourse server. So the test runner has that client in its JVM and it interacts with the Concourse server JVM. But the cool thing is that you can actually write end-to-end tests that use any version of or any version that's still in development. And so what that actually looks like, there are a couple of different things you can do with end-to-end testing, right? So if you have the end-to-end testing framework and you extend this client server test class, well, it's going to force you to provide a value for this get server version method. And you can actually give it the version of the server that you want this test to run against. And if you notice on the lower part of this screenshot, you'll see what it's actually doing, right? It's saying it couldn't find the installer for that version in my home directory. So it actually goes and downloads that version from GitHub, right? All of our release binaries are posted to GitHub. Version, installs it, starts it, and runs it, runs my test, and after my test passes, it stops the server and deletes it. It deletes the server and all the data. It does all of that for you automatically, right? So, hey, I've got some app. I just want to write some test. I don't have to worry about the database, but I know that I'm actually getting a realistic test because it's going to use the real database. It's literally going out and downloading the exact release installer. The second thing you can do is something that I think is cool, is a cross-version test. So there are some times when you may want to test how the same piece of code or the same test case works against different versions of Concourse. So perhaps, and it works, and then you want to be able to run that against a new release or a new version. And so you just want to say, okay, I want to make sure that the data that I get in this version looks the same as another version, right? Or maybe there was a bug in a previous version, or maybe there was something in a previous version of Concourse that was causing bugs. So I want to actually test and make sure that, yes, that bug exists in another version, but it's fixed in a later version. So you can do this thing called a cross-version test. So if you extend the cross-version test class and you annotate that with an array of all the versions that you want to test against, you'll notice that this test runner, what it's doing, it's running the same test against all those different versions, and it annotates as which result. So, in 0.34, this failed. So we actually had a case where there was a bug in version 0.34 of Concourse where you could add circular links, and that was fixed. And so you can see that, yes, in a later version, in 044, it's fixed. And then also in the latest version, it's fixed, right? And so you'll notice in I'm able to specify latest for the version that I want. And what happens if you do that, and this is really cool, is that the test runner will actually go out to GitHub and it will clone the latest development version of the code base. And it's also smart enough to know that, hey, if you're actually writing a cross-version test or a test that needs to run against the latest version, but you're writing this test and you're writing it from either a clone or a fork of the Concourse repository, it's smart enough to know that, and it's not going to go to GitHub because it has the source code already. And so it'll just use that. So you'll notice that it'll get the source code, it'll build the installer, it'll install it, again, same routine, start it up, run it, stop it, delete it, right? All of this is managed for you automatically. You as a developer don't have to worry about it. Another cool thing is that, again, you can use any version, right? So if you're using a version of the test framework that's interacting and you want to test against an older version, right? So let's say you're using the latest version of the version that has methods that no longer exist. Well, there's a special hook where you can call arbitrary methods on the client that the E2E test framework gives you, and you can simply give it a method by name and the parameters, and it will intelligently be able to do that. And the reason it's able to do that is because the client that it's using is from the external JVM. It's not using the client that you have as a dependency of the test framework. It's actually intelligent enough to go out and use the client that is provided by the external JVM, right? So there's a lot of logic going on behind the scenes to make that possible. And then the last part, the E2E test framework, is you can do upgrade tests. So an upgrade test allows you to test that certain upgrade actions are possible, right? It allows you to test that something that happens that exists in one version of Concourse is still there when you upgrade, right? So let's say that you're worried about upgrading and you want to make sure that, you know, certain data doesn't get transformed, or maybe there were some changes in Concourse and you want to make sure that stuff doesn't happen on upgrade that's going to affect you in a negative way. And so if you extend upgrade tests, again, it will force you to say, provide the initial server version that you want, and then it's going to, right? So this is similar to the hook, the before each test hook, right? This is a hook that allows you to set the state of Concourse that you want prior to the upgrade. So it's actually going to go through and execute whatever actions you specify before it does the upgrade. And then if you look at the log, right? And so what it does, it installs the initial version of the server you want. It starts that up. It runs the pre-upgrade actions. It stops that. It upgrades the version of Concourse server. Then it starts it up again. And then it actually runs each of your unit tests. So every unit test that you have in this test class, it'll actually run all of those against the upgraded version of Concourse. And so that is a great way, again, a great way for developers to say, okay, I want to use Concourse and I want to be good about writing unit tests. Well, I have this framework that's going to automate everything to do with Concourse. But again, it's going to do it realistically. This is actually a server that's downloaded, installed, and running. This is not a mock. This is not embedded. It's none of that. It's an actual version of Concourse server. So it is very realistic, and you get the same thing that would happen if you were running this in production. Now, before I continue, I'm going to check in to see anyone have questions, or I know we're going through a lot, and we're actually getting through it a lot faster than I anticipated. So anyone have questions? If so, go ahead and email me, or you know, paste them into the group chat, whatever the case may be. You can message me on Slack. However you need to get in touch with me, go ahead and do so. I'm going to continue on, share my screen again, and share the slideshow. Oops, sorry about that. Cool. So I want to talk about MyCourse. MyCourse is an in-memory implementation of Concourse server, and this is for cross-language integration tests. So notice, it's for integration tests, not for end-to-end tests. We don't expose MyCourse to third-party apps and tell them to use this to test their code against Concourse, because the name suggests it's sort of like a mock. And MyCourse is interesting, right? So it's in memory, so it doesn't actually store anything on disk. It has very basic, often brute force implementations of the methods that are found in Concourse server. However, it uses thrift, just like Concourse server does, so it works with all client interfaces. So you can start MyCourse up, and you can use it with Concourse shell. You can use it with any of the client drivers. You can use it from the Java driver. You can use it with anything you would normally use Concourse with. And its design is to ensure that clients are correctly serializing and deserializing data. So again, it's for integration testing. So it's really to test, okay, can the client send data over to the wire correctly? And can the client get data from across the wire and deserialize it correctly? That's really what MyCourse is intended for. So drivers should have their own unit test that tests whatever they do that's driver specific, and Concourse has its own unit test. But MyCourse is really the cross-language way for any driver to sort of test that sort of integration point of serialization and deserialization. And another limitation of MyCourse is that it can only serve as one client at a time. So you'll notice those test runners are lined up. So if you've got multiple clients connected to a single instance, be able to do stuff at a time. So that's a limitation. It's not a multi-threaded instance of the interface. But it's cool, right? So you can control this from the command line, right? As I mentioned, it's actually you know, a legit thing. And I'll just do a quick demo, right? So clear that, right? And I'm going to start up MyCourse, and I've got a messy development state. So what happens when you're constantly deving on things, right? So I've got MyCourse up and running, and I'm going to do, if I connect, and MyCourse by default runs on port 1818, but you can give it a different port, right? So I can connect using Concourse shell. I can connect to it, and you can see that it's connected to the MyCourse environment, right? And so, you know, I can add some data. I'm able to use all the things that I would normally do, right? Right, this is a actual implementation. However, it's all in memory, and you know, that's one limitation. And I can only have one client connect at a time. So gonna kill that, right? You'll notice it dies, right? Because MyCourse is now down. But that's one of the cool thing about Concourse is you can control it from the command line, but you can also control it from the source code. So in all of our drivers, right, we strive to make our goal is to make it so easy for developers to write unit tests that they don't have to think about anything but the test that they want to write. They don't have to worry about fixtures and harnesses and this or that. They just write test code. And so all of our drivers actually control MyCourse from the source code, right? So they actually are able to start it up, create clients, just like the integration test framework that we have in Java. Our driver code is able to use that as well. And it allows you to do this familiar usage that you would do with the integration testing framework. So you're given a client, and you can call the same methods from that client that you would be able to do as if you're actually using the client in real life third-party code, right? So it's really cool. And MyCourse, again, is the mock implementation of this because we're only trying to test whether the drivers can communicate, can serialize and deserialize correctly. We're not actually concerned with the correctness of their implementations, just the serialization and deserialization. But it allows you to write those tests in a very sane way that's familiar to writing integration tests. And it can intelligently discover, which processes belong to it, right? So if you're multiple driver tests concurrently, and they're all starting up instances of MyCourse, you can have as many instances of MyCourse as you want. The drivers are intelligent enough to figure out, okay, which MyCourse instances did I start? And let me make sure that I manage those. I make sure that I close those down at the end of the test. I make sure that those processes aren't hanging around and become zombie processes. And so the last thing that I want to talk about is just command line testing. And so this is currently experimental, but Concourse provides a lot of command line interfaces. And we want to be able to test those programmatically as well. We don't want to have to always have people manually call CLIs or do stuff on the command line in order to test that. So we actually extend a unit testing framework called BATS, B-A-T-S, to do this. And so for command line testing, it allows you to write a test case in Bash, right? You can actually do that. And you're actually just using Bash code, and you can validate output of CLIs. You can compare variables. You can do all sorts of stuff that you do in any normal programmatic test. But again, all of this is managed for you. You can just say, hey, I want to start Concourse. But again, you just tell it to do it. You don't have to manually do that. It's going to take care to actually, again, install Concourse for you, make sure, then clean it up afterwards, right? And it gives you, like, you can run these from the command line. So we've got a util that lets you run all the Bash tests. And it'll run those, and if they all pass, great. If one of them fails, then it'll let you know that there was a failure. So that was my presentation. We got through this a lot faster than I anticipated. I scheduled this talk to be closer to 90 minutes, but looks like we've still got some time. So just want to know if anyone has questions about anything, go ahead and email me or post them to the mailing list, or get it, and I'll be happy to answer those. But hopefully this talk was helpful. Hopefully it provided some insight into how we think about unit testing or testing in general and Concourse, what tools we've created to make it so easy to do unit testing and programmatic testing that you don't have to think about it, and how you should use those tools. So this video will be recorded and posted to YouTube. Thank you so much for tuning in, and thank you for watching, and thank you for being a part of the community. We really appreciate all you're doing. We're building a great product, and it wouldn't be possible without the help of so many passionate contributors. So thank